Take a look around you. I bet you're surrounded by things made of perfectly bent metal. But have you ever stopped to think about how a simple, flat sheet gets turned into a really complex part? Well, today we're diving into the machine that makes it all happen, the CNC Press Brake. Let's get right into it.
I mean, it kind of feels like magic, doesn't it? You start with this plain, flat sheet, and somehow it becomes a super precise bracket, a tough enclosure, maybe even part of a car's frame. The secret is all in a process of incredibly controlled bending, and the machine that pulls it off is the star of our show today.
And this is a feeling almost every new operator has. You're standing in front of this powerful machine, looking at a screen with a ton of options. But here's the thing, once you get the core logic behind it, it all starts to click. So we're going to follow that journey, from being a beginner to becoming a pro. So what is the modern answer for bending metal with just incredible accuracy? Well, it's the CNC, or Computer Numerical Control Press Brake, and let me tell you, it's a massive leap forward from the old manual ways of doing things. The real genius of the CNC press brake is how it takes the operator's plan, the type of material, its thickness, the angles you're trying to hit, and it automatically figures out all the complex movements needed to make it happen. It's all about precision and, maybe even more importantly, consistency. All right, so to really understand how it all works, let's do a little anatomy lesson. We're going to break down the machine and meet the key parts that an operator uses to actually shape the metal. First up is the ram. Now, this isn't just one big, solid piece moving down. It's actually controlled by two independent hydraulic cylinders. We call them Y1 and Y2. This setup lets the machine make constant, tiny adjustments on the fly, keeping that ram perfectly parallel to the table. And that is the secret to getting a straight, consistent bend every single time. So if the ram is the muscle, then the tooling is the hands. The top tool is called the punch, and that V-shaped tool on the bottom is the die. The punch pushes the metal sheet down into the die, forcing it to bend. And picking the right punch and die combo is one of the most critical decisions an operator has to make. It affects the final angle, the curve of the bend, even how much force you need. Oh, this thing is a total game changer. Back in the day, you'd be messing around with a tape measure, drawing lines. Not anymore. The backgauge is an automated stopper that moves forward and back. The operator just slides the sheet metal up against it and boom, it's in the absolute perfect spot for the bend. This is a brilliant example of how automation gets rid of human error and just massively speeds up the whole process. And here we have the brain, the place where the operator's plan becomes the machine's action. The operator tells the controller everything it needs to know, and then the controller just crunches all the numbers. It figures out exactly how far the ram needs to come down and exactly where the backgauge needs to be. It's basically the central nervous system for the whole operation. Okay, now we're getting to the real secret sauce of bending metal. This is the one concept that every new operator has to master. It's that aha moment that explains why bending isn't nearly as simple as it looks on the surface. Think about it like this. When you first start to bend a piece of metal, it's in a state of elastic deformation, kind of like a plastic ruler. You can bend it a bit and it'll just snap right back. To make a bend permanent, you've got to push that metal past its elastic limit and into what's called plastic deformation. That's when the change actually sticks. That's our goal. But, and here's the catch, even after you've made a permanent bend, the metal still has this thing called elastic memory. It wants to go back, just a tiny bit, to its original flat shape. So when the machine lets go and releases the pressure, the angle actually opens up a little. This effect is called springback, and it is without a doubt the single biggest challenge in precision bending. So how does the machine handle this? Well, it basically outsmarts the metal. The CNC controller knows springback is going to happen, so it plans for it. To get a perfect 90-degree angle, it calculates that it actually needs to bend the metal further, let's say to 88 degrees. Then, when it releases the pressure and the metal springs back, it lands perfectly on the 90-degree target. It's a brilliant, intelligent overbend. Okay, so we've met the machine, and we've learned its biggest secret. Now let's put it all together and see how an operator uses all this knowledge in a clear, repeatable workflow to go from just a program on a screen to a real physical part. It really just boils down to these 4 key steps. First, you program the part in the controller. Then, you prepare the machine. That means picking the right tooling and getting it installed safely. Step 3 is the big one, the first trial bend. This is where theory meets reality. And finally, you check that first part with a protractor. If the angle's off by just a hair, you make a tiny tweak in the program, and then you're ready to roll for production.
Going from a beginner to a true professional is about so much more than just pushing buttons. It's really about developing a mindset, a way of thinking that mixes technical skill with a deep understanding of quality and, most importantly of all, safety.
A truly skilled operator thinks like a detective. The finished part is just full of clues. So for example, if the angle is dead on in the middle but opens up at the ends, they know to check the machine's crowning system. That's a feature that actually counteracts the machine's own tendency to flex under all that pressure. If a flange length is wrong, they check the backgauge. The part tells a story, and a master operator knows exactly how to read it. And this all leads to the habits that really define mastery. It's about situational awareness, always knowing where your hands are. It's about doing consistent checks and having a troubleshooter's mindset, where you want to understand the root cause of a problem, not just patch it. And at its core, it's about treating safety systems not as some annoyance, but as your essential partner in the whole process. These are the things that separate an operator from a true artisan. I absolutely love this quote because it just gets right to the heart of it all. The CNC controller is an unbelievably powerful tool for sure, but it's not a replacement for the operator's skill, their experience, or their intellect. The best operators use the machine to execute a plan they've already reasoned out. The human is and always will be the most important part of this process. So, the next time you see a metal box or a filing cabinet, maybe even a street sign, you'll know the secret. You'll see those clean, crisp bends, and you'll understand the incredible dance of force, tooling, and intelligent thinking that had to happen to create them. What everyday objects are you going to look at with a whole new appreciation now? Thanks for joining me.